Alright everybody, today we're going to talk about factoring the sum and difference of cubes. And there's just a couple formulas that you're going to have to remember for this factoring technique. Now, notice that when we have the sum of cubes right here with the plus sign, you have a cubed plus b cubed equals the quantity a plus b times a squared minus ab plus b squared. But when we have a cubed minus b cubed, we have a minus b, but then this is a plus. Whereas up here when we had a plus, this sign here was a minus. So the most common problem is for people to forget about the sign pattern with these expressions. So there's an acronym that you can use to remember the sign pattern, and it's called SOAP. S-O-A-P. Now here's what SOAP means. SOAP means the S is for same. And what same denotes is that if this is a plus, then the sign in the binomial in the factored form is the same. So plus, same, plus, minus, same, minus. The O stands for opposite. I'm going to abbreviate there. So O is the opposite. So what that means is the next sign in the pattern, which is the first one in the trinomial, if your original binomial has a plus, then this sign is always the opposite, so that's a minus. Notice here with a minus, this is a plus. So this sign here is always opposite this sign here, in the same case here and here. Now, excuse me, the A is always. So A stands for always. And then the P is positive. Okay, so what that means is the last sign in the factored form, or the trinomial in this expression, is always positive. In both cases, notice plus here, plus here. So we have same, opposite, always positive. And then, of course, you have to know the two formulas. This is pretty straightforward, but let's just go through a couple examples. So notice if our expression is y cubed minus 27, we can factor this with difference of cubes. Okay, if it helps you, go ahead and rewrite this as the quantity y cubed minus the quantity 3 cubed, if that helps you to see what the actual values are that are being cubed there. All right, and then let's just use that pattern. So notice we have y cubed minus 3 cubed, so our first term in our binomial is just y, and then the sign is the same here, because if this is a minus, then this is a minus, so that's just y minus 3, right? And then quantity, then the first term is always just this term squared, so we have y squared. Now be careful with the sign here again. Remember, if this is a minus, this sign in here is going to be opposite, so this becomes a plus. The middle term, once you have this first binomial done, is always just this times this, so that's a 3y. And then the last sign is, remember, that's always positive, so this is a plus, and then that last term is always just this thing squared, so that becomes 9. So we have y minus 3, quantity y minus 3 times the quantity y squared plus 3y plus 9. And remember, if you wanted to check this, if you multiply this whole thing out, you will end up with y cubed minus 27. Okay, here's one with a sum of cubes. And notice once again, excuse me, if we have w cubed plus 64, then this becomes, or is the same as, I should say, w cubed plus 4 cubed. So we simply have the first binomial part of this factored is just w, the sign is the same, so that's plus 4. right? Then we move to our trinomial part. The first term is this thing squared, so we have w squared. Now remember the sign. If this is a plus, this sign in here is going to be a minus, so we have a minus, and then these two terms multiplied together, so that gives us a 4w with an always positive last sign, and then this term squared, which is 16. And we're done. Multiply that out if you'd like to check. Now the first two were just basic examples to show you the pattern. The next one is something maybe that you will come across more frequently, because not everything appears to be a sum or difference of cubes in its original form. But don't forget, always the first step for any factoring problem should be to look for the GCF. Now we ignored that on the first two just to show you the pattern. So here we go with the GCF. Okay, so notice we can take a 2x squared out of both of these terms. So if we take a 2x squared out, we're left with just 8 plus 125x cubed. Now notice both 8 and 125x cubed are perfect cubes. 2 cubed is 8, 5x quantity cubed is 125x cubed. So we continue factoring using our formula, and don't forget to bring that GCF down with you every step. So we have 2x squared, then the cube root of 8 is 2, so this becomes a 2 plus, because that first sign is the same, and then this is 5x, right? Then in our trinomial, the first term is this thing squared, which is 4. The next sign, now remember, if this is a plus, our sign in here is always going to be opposite, so this is a minus sign. Then the middle term is always this times this, which gives us a 10x. And then our last sign is always positive, and it's just this term squared. Watch out for the common mistake here, though. It's 25x squared, though, because of that x. And so we have our final fully factored expression. And of course, if you do want to take the time to check these, you could multiply all that out, and you should get 16x squared plus 250x to the 5th. So there you have it. There's factoring sum and difference of cubes. So I've got a couple problems here that I'd like for you to try on your own, and then just bring them to class with you tomorrow so that you can verify that you've watched the video and that you know how to do this task. Then I'll have some more practice problems like this for you to continue with. Remember, you may need to go back and watch this video again, or hopefully you took some notes and at least wrote those formulas down. Remember, it's always a good idea as you're watching these videos to take some notes, write things down, write examples down, or if you prefer, just keep going back through and watching the video and pausing the video. It's there for your help.